Hi, and welcome to a quick introduction to Bastion high-availability PostgreSQL clusters using FreeBSD and Bastille containers.
The FreeBSD community doesn't have a common high-availability framework such as Cluster Labs Linux HA, but that's because we really don't need one. Although Pacemaker and CoreSync are available from ports, they are cumbersome and complex to set up and don't play well with BSD idiosyncrasies, and especially don't work very well in jails or native FreeBSD containers. FreeBSD already provides native high-availability primitives such as carp and hast, along with all the features and benefits of ZFS that together provide a rich toolkit to create high-availability clusters out of the box. So what is Bastion and what is BastionPg? Bastion is a generic toolkit to create high-availability clusters using Bastille containers and FreeBSD. BastionPg is a PostgreSQL cluster manager to create and monitor high-availability database clusters built with the Bastion toolkit. Let's watch a short demonstration on how BastionPg can help you create a high-availability PostgreSQL cluster in just a few minutes. The live demonstration is split into two parts. This first part will show the cluster creation, and the second part will focus on failover and recovery. Let's add our master database container. We give our container a name and a fixed IP. We also have to provide a carp group ID, which must be unique for every database cluster. Next, we specify the client IP, which is a floating carp IP to which clients will connect to. Finally, we indicate that this will be our master node container. The master container is created. We must make sure to map the carp events so they are dispatched to the correct container. The group ID we specified earlier will be included in the event name, and we must make sure this event is dispatched to our new container. Just add a new entry into the carp control mapping file, as shown. Now we go into the new container and continue the setup there, using the hints provided by the container creation script, and a continuation script that has been prepared for this container. Here we specify the role of this container and two nodes that will form part of the high availability cluster. It's okay to include the standby node's IP even if that node hasn't been created yet. Once the node is fully configured, you need to save the temporary random passwords that have been created for the Postgres and replication users. You can also copy the public key at this time if you want to add SSH trust between all cluster nodes, but you can do this at another time as well. We can now verify the master node to see if it's working properly. The virtual interface VNet0 has the fixed IP and the carp IP as well. You can notice that this carp IP is in master mode and that the advertisement skew is 0, which should preempt any other interface trying to get master role. You can also perform a process list and verify that this Postgres is acting as a master database node. The WallWriter process is a giveaway of this. At this time, we can go into our client application and connect to this database using the carp client IP. Clients should never connect to the container's fixed IP. After connecting to the carp IP, we can verify we are on the right server by issuing a few PSQL commands. We will now create a replication test database and verify its existence on the master node server locally. We will now proceed to create the hot standby Postgres server, named Cluster2 Node 2. Notice that the fixed IP 10.77.8.21 is different from the master node's fixed IP of 10.77.8.20. But the client IP 10.77.8.120 is the same for both nodes. BastionPg will automatically set the CARP parameters according to the role of this node, in this case, the standby node, and set up the network interface with the correct backup status and advertisement SKU. After the node is created, we follow the same procedure inside the container, as we did with the master node's container earlier. But before we do so, we must remember to set up the CARP event mapping file, and add a new mapping entry for the CARP group ID in this new database cluster container. BastionPg will dispatch CARP events to the correct container, regardless if they are in master or standby mode. Now that the standby container is fully configured, we can perform some spot checks to verify it is working correctly. First, we can check the virtual interface and verify that both IPs have been assigned, and that the CARP IP is in fact in backup state, and that the advertisement SKU value is much higher than the master. Also, from the client we will create another database to test live replication. And finally, we will run a special query on the master node to verify the status of our standby replication as it is seen by the Postgres master. This is the end of part 1, the basic introduction to BastionPg, and how easy it is to create a basic 2-node PostgreSQL high availability cluster with BastionPg. Make sure to check out part 2, where we demonstrate how BastionPg handles failover and recovery of both master and hot standby nodes with ease. Thank you so much for watching.